Hi everyone, and welcome to this lecture. So here we will finally run the algorithm to find the best antibodies and the best solutions. So let's get started. Let's create a population of 30 individuals. Pop equals population 30. Let's define 100 iterations for I in range 100. Let's define the affinities, affin antibodies for the population. Bests equal select affin for. We'll select the 4 best antibodies. Let's define the variable clone. Cloning 25 bests. Hypermutation clones 0.1. Here is actually clone. Let's define the variable called nnews, which is the length of the population minus the length of the hypermutated antibody. For I in range nnews hypermute.append antibodies. So here we are going to select completely new antibodies to replenish the population. Pop equals hypermute. The original antibodies are now the hypermutated antibodies. Print pop index 0, the first antibody. Print affinity pop 0 in number. Print. Here we are going to generate an image for each antibody. Picture equals pop index 0. Array image will be an empty list. Init will be 0 and end will be 11. Yn is less than the length of picture minus 1. Array equal picture init and array image dot append array. Here we are going to update init and end. Image equals np dot array image fig x plt dot subplots im equals x dot imshow image x set title number fig.type layout and plt.show. We have a little error here. Now we can see the antibodies being generated and their respective affinities. Here we have the increasing affinities of the antibodies. 115, for example, 116, 118. We are reaching 100% affinity. So here we have the end of the iterations. We got very close to 121 of affinity. So we can see that these antibodies here are very similar to the antigen, which is the number 8. And the antibodies here from the beginning are completely different. They are completely random, where we run the algorithm. In the next lecture, we will build a graph for the solutions. I see you in the next lecture.